Welcome everyone to our podcast on the future of work with AI agents. Today we'll dive deep into auditing, automation, and augmentation potential across the U.S. workforce.
Thanks for having us. I'm excited to discuss how this new auditing framework challenges the old automate or not dichotomy and introduces the human agency scale to redefine worker and expert expectations.
Absolutely, and what excites me is the technical nuance. Using a task-level audit drawn from the ONET database gives us a granular perspective on which tasks workers actually desire to automate versus those they prefer to augment.
Right? And when you layer in expert assessments of current AI capabilities alongside worker preferences, it really paints a clear picture of the four zones: green light, red light, R&D opportunity, and low priority.
And let's not forget the technical side. The integration of LLMs with multi-step execution and tool access is transforming how these AI agents are being built, almost like crafting a digital Swiss Army knife for the workplace.
From a strategic business perspective, this framework is a game changer. Imagine being able to map investments in AI exactly to tasks that workers both desire and that are technically feasible, rather than just dreaming up the next flashy startup.
That's a fantastic point. The paper even shows that, for instance, tasks in sectors like content creation might show lower automation desire despite high AI usage, highlighting potential misalignments.
Exactly. Take the example of video game designers who typically resist automation in creative content, preferring a collaborative human-agent partnership, which aligns with their high human agency scale ratings.
And on the technical side, the auditing framework employs audio-enhanced mini-interviews to capture worker insights, ensuring that qualitative nuances are not lost in a dry numerical survey, which is key for robust AI development.
I'd add that the methodology of comparing worker ratings with expert assessments via the Hass spectrum provides us with a quantitative measure, such as the Jensen-Shannon divergence, to decide how aligned or misaligned worker desires are with current AI capabilities.
That metric is fascinating because it's not just about automation. It shows that in many occupations, workers want a middle ground, H3, which means AI agents should function as equal partners rather than replacements.
And from the business lens, implementing this balanced approach can drive productivity without triggering the common fear of job displacement, a fear echoed by 23% of workers in the study.
Speaking of fears, the study also highlights concerns like lack of trust in AI's accuracy and reliability. What do you all make of that in terms of adoption challenges?
Well, I think it's a natural human response. The sentiment, "I want to free up time for high-value work," shows that workers are eager for assistance, but not at the cost of losing the human touch in critical decision-making.
To elaborate technically, current LLM-driven agents are evaluated on a multi-step execution capability, which means they can perform workflows. But the challenge is to engineer systems where error correction is built in, effectively mimicking a human collaborator's oversight.
A great example is the use of role-based support. Workers often mention wanting an AI agent dedicated to specific subtasks while retaining direct control over final decisions. A model that's reminiscent of assistantship, but with more sophistication.
And this is where the layered design of the human agency scale becomes key. The difference between H1 automation and H3 collaborative modes is like comparing a self-driving car with one that lets you override the system when needed.
From the business side, consider a retail company that integrated similar human-AI collaboration models. They reported a 15% cost reduction while maintaining customer trust, because customers still valued the personal service touch.
That's a perfect segue. Technical insights meeting business outcomes. How do you see the desire capability landscape affecting investment decisions in the startup ecosystem?
The mapping of Y Combinator companies against the four zones reveals surprising trends. Many investments are funneling into domains with high capability but low worker desire, the so-called red light zone, which could lead to misaligned products.
Precisely, and this is where a technical pivot is needed, encouraging R&D efforts to focus more on the green light and opportunity zones, where both worker desire and technical feasibility intersect.
One technical strategy could involve iterative development, where AI agents are updated constantly using feedback loops from worker interviews. This agile approach can reduce the misalignment over time.
And let's not underestimate the complexity here. The underlying algorithms must adapt to diverse occupational tasks, which means built-in modularity and scalability in the AI systems to handle everything from data entry to strategic planning.
Strategically, companies need to balance between chasing the latest flashy technology and investing in robust systems that augment rather than replace human capabilities. This framework offers a roadmap for that balanced approach.
Interesting. So while we're designing these systems, what technical hurdles remain around ensuring they can handle the spectrum from pure automation to augmentation?
Among the challenges is capturing the nuance of human decision-making. Training AI models to recognize context in multi-step workflows isn't trivial. It's like teaching a computer to appreciate the subtle art of conversation.
Exactly. And the technical heavy lifting comes with designing interfaces that support audio-enhanced feedback and natural language processing at a scale that supports complex, multi-layered task assessment.
We're talking robust error reporting, advanced anomaly detection, and even incorporating reinforcement learning, where the AI learns from periodic human corrections, a true feedback loop.
And don't forget the integration with legacy systems. Many organizations still rely on older software stacks, so ensuring that these AI agents can seamlessly interact without disruptions is a major engineering challenge.
From a business perspective, such integration challenges may slow down rollout, but they also provide an opportunity for companies to gradually adapt and train their workforce, turning a potential risk into a strategic development phase.
That's a compelling vision, a truly adaptive system evolving alongside workforce needs. How have industry players approached this integration in real-world applications?
One interesting case is a financial services firm that re-engineered their credit analysis workflow. AI took over repetitive data tasks, while human experts focused on nuanced risk assessment, directly reflecting the HASS spectrum findings.
Technically, that involved a hybrid model where the system autonomously parsed financial statements and flagged anomalies, yet allowed human oversight for final decision-making, essentially an H3 mode collaboration.
And similar experiments have been run in healthcare support, where initial diagnostic data are processed through AI agents, but physicians provide the final judgment, a perfect illustration of augmentation over replacement.
Those implementations required integrating multiple models, natural language processors to decipher reports, decision trees for anomaly detection, and even clustering algorithms to group similar patient data, a real technical tour de force.
And on the strategic side, these applications not only boost efficiency, but also foster greater trust among workers and customers, as the human element remains preserved, ensuring that technology serves as an enhancer rather than a disruptor.
Incredible insights. This balance of maintaining human ingenuity while leveraging AI efficiency sounds like the future itself. Are there any contrarian views among you?
Well, I'd say while many focus on efficiency gains, I think we might be underestimating the potential for AI to introduce new forms of creativity and strategy beyond what we traditionally assign as automation.
I see your point, but I'd argue that without strong safety nets and interpretability measures, we risk creating inadvertently opaque systems. So the drive for creativity must always be balanced with accountability.
Building on that, remember the old adage, trust but verify. And for AI agents, verification becomes a technical imperative. We need transparent decision-making frameworks to ensure that our human collaborators always remain in the loop.
Exactly. I often use the analogy of a chef and a sous chef, where the chef retains creative control even though much of the prep work is handled by the assistant. If you lose that dynamic, the dish suffers.
And from a business standpoint, the entire value proposition of integrating AI hinges on that human touch. Companies that neglect it may reap short-term gains but risk long-term disengagement from both employees and customers.
This conversation has been a goldmine of perspectives, from technical challenges to strategic implementations. Before we wrap up, any final thoughts on the path forward for AI agents in the workforce?
I'd say continuous collaboration between developers, domain workers, and business strategists is key, as is adopting auditing frameworks like Workbank to ensure that AI evolves in tandem with human needs.
Technical innovation must be iterative and responsive, integrating robust feedback mechanisms that allow AI systems to adjust to dynamic real-world conditions.
And let's keep experimenting with novel collaboration paradigms, pushing the boundaries of what augmentation can really look like in complex workflows, while ensuring human oversight remains integral.
I'd also emphasize scalability and interoperability. As our systems mature, building flexible architectures that can adapt to various industries will be the cornerstone of successful AI integration.
Finally, from a strategic lens, aligning investment with worker-desired outcomes and cultivating a culture of innovation rather than disruption will determine how seamlessly AI agents can enhance our future of work.
Thanks everyone for this enlightening discussion. Bridging deep technical insights with strategic business applications truly shows that the future of AI in workforce management is as challenging as it is promising.
It's been a pleasure sharing our perspectives. Here's to building smarter, more collaborative workplaces ahead.
Thank you, and I'm excited to see these frameworks evolve as more real-world data comes in.
Absolutely. The journey of fusion between human intuition and AI capability is just beginning.
Here's to a future where technology enhances the best of human skills, not replaces them.
And to companies that take a balanced, thoughtful approach, ensuring that innovation not only drives efficiency, but also enriches the human experience in the workplace.
Welcome back to part 2 of our discussion, where we dive into the technical deep dive of the auditing framework and its practical implementations.
Let's start with the backbone of the system, the audio-enhanced mini-interviews that capture worker sentiments naturally, which are then processed using advanced NLP techniques to extract key features.
Right. These interviews are passed through models like GPT-4 for sentiment extraction and topic clustering, allowing us to generate a nuanced view of worker automation desires down to each occupational task.
And more technically, the system employs transformer-based architectures to convert these free-form audio transcripts into structured, quantifiable data that feeds into our human agency scale assessments.
Exactly. The integration of audio processing with structured survey data ensures that we capture both qualitative insights and quantitative ratings, which we then process using statistical measures like Jensen-Shannon divergence.
From a business case perspective, this means companies can directly observe which tasks need higher human oversight versus full automation, enabling targeted investment in areas that truly matter.
Could someone break down how the auditing mechanism segments tasks into the 4 zones based on desire and technological capability?
Sure, the system maps tasks by combining worker automation desire scores with expert assessments of current AI capability. This results in a 2-dimensional grid where tasks fall into green light, red light, R&D opportunity, or low priority zones.
On the technical side, the mapping involves normalizing worker input on a Likert scale and then comparing it to expert ratings with a statistical correlation model, highlighting gaps where worker desire for collaboration doesn't match technological feasibility.
To add, a key algorithm used here is the iterative clustering algorithm that analyzes task-specific characteristics like repetitive nature, decision complexity, or interpersonal needs to produce a layered categorization.
And this clustering isn't static. It continuously updates as new worker survey data and AI research findings come in, essentially creating a dynamic feedback loop that informs R&D projects.
From a business standpoint, this dynamic approach is crucial. It means that investment strategies can be realigned in near real time, addressing emerging opportunities in high-growth sectors while minimizing resistance in low-desire zones.
Fascinating. Now, what about the technical challenges of integrating these systems with legacy enterprise infrastructures?
Integration is a major hurdle. Many companies run on outdated systems, so our approach leverages modular APIs that allow the AI agents to interface with existing workflow management systems without causing disruptions.
Technically, this involves designing middleware that translates between legacy data formats and the modern JSON protocols our AI systems use, ensuring seamless communication between old and new systems.
Furthermore, the implementation includes robust error handling routines and real-time anomaly detection, so that if the AI agent misinterprets a task's context, it flags that task for human review immediately.
And by incorporating reinforcement learning models, the system learns from each human correction, thereby gradually increasing its accuracy and reducing future intervention needs. A real win in system reliability.
In practical business scenarios, such integration not only improves operational efficiency, but also reduces training costs, since existing teams can adapt without overhauling their entire infrastructure.
On the subject of reinforcement learning, can you explain how feedback loops are implemented in this framework?
Absolutely. The process starts when an AI agent completes a task and receives human feedback, which is then fed back into the model as a reward signal, using techniques similar to policy gradients in reinforcement learning.
Essentially, we're applying a model that constantly refines its decision-making pathways based on ongoing evaluations, ensuring the agent's behaviors align closely with preferred human agency levels.
This system uses a hybrid strategy that blends supervised learning on historical data with online learning from live feedback. It's like tuning a guitar by instantaneously adjusting string tension based on the note produced.
A critical component here is the error feedback mechanism, which deploys Bayesian updating to account for uncertainty in worker responses. This probabilistic approach helps the system evolve steadily.
And from a strategic business angle, such continuous improvement translates directly to operational resilience and cost savings, as the system minimizes risks associated with misaligned automation.
Incredible detail. What kind of real-world applications have emerged from this deep technical integration?
One striking example is in the financial sector, where AI agents handle routine data compilation and risk analysis, while human experts step in to review outliers, effectively splitting labor based on task complexity.
Similarly, in healthcare, initial diagnostic data is processed by AI agents, but final decisions remain with physicians, ensuring that high-stake decisions maintain human judgment.
In manufacturing, companies are using these AI systems to monitor quality control. The system interprets sensor data and flags inconsistencies, all while human operators validate the findings, leading to faster turnaround times.
The beauty of this approach is also in its adaptability. Industries as varied as retail and logistics can tailor the AI agent capabilities to exactly suit their operational dynamics without compromising on human oversight.
Ultimately, the actionable insights provided by the auditing framework allow businesses to fine-tune their workflows, drive down operational costs, and enhance customer satisfaction, all while preparing the workforce for a more collaborative future with AI.
This deep dive really underscores how technical innovation coupled with strategic insight can revolutionize workforce management. Thanks for laying out both the microscopic and the macroscopic views.
It's been a pleasure sharing these insights. Bridging the gap between data science and business strategy is truly where value is created.
Agreed. The key is maintaining that balance between automation and human involvement, ensuring that technology becomes an extension of our capabilities.
And as we further refine these systems, The continuous feedback loop will only enhance both efficiency and trust in AI implementations.
Here's to a future where technical innovation and human creativity work hand in hand, paving the way for smarter, more adaptive workplaces.
And to businesses that embrace these advancements, not just for short-term gains, but for sustainable, long-term growth in an ever-evolving market.
Thanks everyone for this insightful technical deep dive. Your expertise has made complex concepts tangible for both technical and business audiences alike. As we near the close of our deep dive, let's recap the journey we took today, bridging complex technical architectures with pragmatic business insights into the future of work with AI agents.
We explored how audio-enhanced worker interviews transform unstructured sentiments into measurable data using transformer models and clustering algorithms, which lay the foundation for our human agency scale.
On the business front, this granular task mapping empowers leaders to pinpoint where automation can free up high-value work and redirect investment into zones that balance AI capability with worker preference.
The dynamic feedback loop, reinforced by reinforcement learning and Bayesian updates, ensures continuous improvement, enabling AI agents to adapt in real time, like tuning a finely crafted instrument based on live audience feedback.
And here's an unexpected insight. While many focus solely on efficiency, our framework reveals that investing in human-agent collaboration not only mitigates job disruption, but also elevates creativity and interpersonal skills, reshaping core competencies over time.
In real-world applications, from finance and healthcare to manufacturing and retail, the system's ability to segment tasks into green light, red light, R&D opportunity, and low-priority zones provides actionable guidance, ensuring technology strengthens both operational resilience and workforce satisfaction.
To sum up, today's discussion has shown that integrating AI agents isn't about replacing human effort, but rather about amplifying our abilities by delivering targeted, real-time insights that align technological prowess with human values. Thanks to all our experts for their rich, engaging contributions. This conversation has underscored that the future of work is a collaborative tapestry of innovation, strategy, and human creativity, setting a clear roadmap for sustainable growth in an ever-evolving market.